Hello everyone. Today we will discuss about the characteristics of the material to be used for making solar cells. So the basic 5 criteria which are written over here are: first is the band gap should be nearly equal to 1 to 1.8 electron volt. 1 means 1 electron volt to a 1.8 electron volt. High optical absorption, that means 10 to the power 4 units per centimeter. That means 1 centimeter 10 to the power 4 units of optical energy absorption must be there. Then we have, it must have high electrical conductivity. Whatever raw material we are using to make a solar cell must be easily available, and it should have a low cost, right? So these are the basic criteria. So on the basis of this, whatever best possible was there are some materials which we will be discussing about in this present video. So what the first thing which comes to your mind is that the solar cell works on solar energy only, but that is not the case. So it does not solely depend on solar energy. Any energy having any energy which is greater than the band gap of the semiconductor will work as a source of energy for a solar cell, right? So we can just mention it over here that solar cell does not work solely on solar energy. Any light with energy greater than its band gap will make it work. And semiconductors with band gap close to 1.5 electron volt are suitable for solar cells, right? So silicon, which has the band gap of nearly 1.1 electron volt, gallium arsenide, which has the band gap of nearly 1.43 electron volt, and cadmium tellurium having energy gap of nearly 1.45 electron volt also is useful. Then we have cadmium indium selenide having energy gap of nearly 1.04 electron volt. So these are the common materials which are suitable for making the solar cell. Now, what are the uses of solar cells? So first thing, we all know that these are used to power the electronic devices in satellites and space vehicles. Right. Second, these are used in calculators. We know that solar calculators are there. We also know that we have solar heaters, solar street lights, etc., etc. So the research is going on to develop low cost photovoltaic cells, or you can say the solar cells. right? We have to discuss, this question is often asked, that why do we prefer silicon or gallium arsenide to make solar cells? Now this is explained on the basis of the solar radiation spectrum which is obtained. So first I'll just mention the question, why silicon or gallium arsenide are preferred for making so for this we will have to draw the solar radiation intensity spectrum, or you can say the solar radiance Now this is observed that near about 1.5 electron volt, the solar irradiance is maximum. So this is the point of maximum solar radiance. So solar radiance, it can also be called as solar irradiance. So this is maximum for 1.5 electron volt. We know that a semiconductor used for solar cell must have an energy gap of nearly 1 to 1.8 electron volt, right? So here we know that silicon has a band gap of 1.1 electron volt and gallium arsenide has the band gap of nearly 1.43 electron volt, right? In some cases it is written as 1.5 something, right? So we can say that gallium arsenide, in spite of having more band gap, is preferred over silicon because of its high absorption coefficient. That means it can absorb the solar energy easily, right? So here small questions may be framed from this part which we are discussing now. So gallium arsenide is preferred in spite of high energy gap, as it has high solar absorption coefficient. Right, so it can absorb the solar energy easily, that's why it is preferred over silicon. We can't use cadmium sulfide or cadmium selenide because these nearly have energy gap of 2.4 electron volt. So if we use this, what will happen, that only the energies of sun which are greater than this value will be utilized and the other energies will be wasted. So we can say here only the higher energies of sunlight will be used and others wasted. So these are not used. Then we have lead sulfide whose energy gap is nearly 0.4 electron volt. So if the energy of sunlight is greater than 0.4 electron volt, all that energy will be used. Now what will be the effect? It will result in the absorption of all the energy by the upper layers. So the energy will not reach near the junction, right? And for effective separation of the electron hole pairs, this energy is required to reach near the junction, right? So here all the by top layers and will not reach near the junction or depletion layer, which is required for the effective separation of electron hole pairs. So this effective separation takes place if this energy reaches near the junction. Now in case this energy gap is very less, all the sunlight energy will be absorbed mostly by the top layer, so it will not reach near the junction. So that's why this is rejected. In this case only the higher energies of sunlight can be used, so this is also rejected. Now in this case, if we compare silicon and gallium arsenide is preferred because of its high absorption coefficient. So it absorbs the solar energy easily. So that's all for now. Hope you have understood the topic. That's all. Thank you.